Today is 4th September and we are starting light energy. See, basically, what is light? Any one of you?
A source of energy,
Yeah, sure.
which helps us to see objects around us.
Which?
Which helps us to see objects around us.
Sir, or light is a form of energy that gives us the sensation of sight.
Light is an energy carried by electromagnetic waves which enhances our sensation of vision. Right? So quickly, reflection of light. I will not go deep into it because this is a topic of class 7. Reflection of light. Whenever a light strikes a smooth and highly polished surface, it bounces back, and this on a perpendicular line to the highly polished reflecting surface. We call it highly smooth and polished reflecting surface. But generally we use the term mirror. Now this is your mirror MM dash. The light which strikes at any point of mirror making some angle. Acha, this perpendicular line is called normal, NN dash. Let me write NN dash. Now suppose there is an incident light AN dash. This is incident ray. Suppose it makes an angle of 30 degree. So it reflects also back with 30 degree. This we have all learned in class 7. Right? That first was incident ray. What were the laws of reflection? Incident ray, normal, refracted ray at the point of incidence. This N dash is the point of incidence. Lying in a same plane. Remember?
Yes.
Everyone is not confident. Boydurjo.
Yes, sir.
Suppose this is a plane, right?
Yes, sir.
And this is the mirror. Okay.
Yes, sir.
This is the normal.
Yes, sir.
This is the normal,
Yes,
right?
sir.
And suppose this is the incident ray, right?
Yes, sir.
Now they are all, the normal
Light.
falls on incident, point of incidence, the, and this is the reflected ray.
Yes, sir.
It is something like this. It is, they are all in same plane. This is, the book is a plane. It is not that the reflected ray is up or the incident ray is up. No. If I take it up, it goes into other plane, na? Some other plane like this.
Yes, sir.
My hand becomes a plane.
Okay, sir.
So first of all, you should not mug up. You should understand they all lying in the same plane. Here, what is the plane? Which is the plane here?
Plane mirror.
Come on, Boidujo, this was the book, this was the plane here.
Yes, sir. I thought you were referring to the board.
This was
Yes,
the
sir.
mirror,
Yes, sir.
right?
Yes, sir.
This was the incident ray, and this was the normal. They were lying in the plane of the book.
Okay, sir.
Here, what is the plane?
Here, sir, the plane mirror.
No, the board is the plane.
Oh,
Only when you draw this diagram, your copy paper, that is
oh,
the
okay.
plane.
That means the part where we draw the plane mirror or the incident ray or the reflected or normal ray, normal, then that becomes the plane.
All same plane. It is not that A N dash. Can you see A N dash
Yes, sir.
is slightly up? A N dash is not like this. A N dash is attached to this plane. It is not like this.
Okay, sir.
B N dash is not behind this or lower to the plane.
Yes,
Got
sir.
my point?
Yes, sir.
If I keep my board horizontally, then that becomes a plane or not,
Yes, sir. That becomes a plane.
right? That
Yes, sir.
becomes a horizontal plane. And this is nearly a vertical plane. Right?
Yes, sir.
Plane is nothing. Plane is a surface area. Is a
Okay.
surface,
Yes, sir.
right?
Yes, sir.
Chalo, note it down. Pratyasha, how is your father now?
Sir, good.
All problems sorted?
Yes, sir.
No pain?
No, sir. In the back, there is still pain. He couldn't
Acha.
stand for a long time.
Make the diagrams using pencil and scale. Let me know once it is done.
Yes, sir, done.
Yes, sir. Done.
Okay, this was a recap of class 7, right?
Yes, sir.
Now, basically, what is refraction of light? First of all, one important thing is that light has different speeds. Light has different speeds in different. We don't write mediums, we write media. Full form of medium is media. Speed of light. Speed of light. Note it down. There is a symbol for this. Small c. In vacuum or air, it is 3 into 10 to the power, sorry, 3 into 10 to the power 8 meter per second. Clear?
Yes, sir.
Is it clear?
Yes, sir.
Speed of light c in water, it is 2.25 into 10 to the power 8 meter per second. Speed of light c in glass, only glass, it is only 2 into 10 to the power 8 meter per second. Now, if I write speed of light in air, that is C air or CV, C vacuum, is greater than C water, is greater than C glass. Is there any confusion?
No, sir.
No, sir.
So C air, C water, and C glass. Now in your school, they must have told you what is refraction. The change in path in path of the incident light when it is traveling when it is traveling from one medium, one transparent medium to another. Is that clear? Acha,
Yes, sir.
here I forgot to tell you. There is something called optical density. You should not be confusing as it with mass density. Optical density is a different term, right? Clear? And we will talk about optical density little later. Now we have found it experimentally. Acha, we were here. Refraction is essentially a surface phenomena. Now look at the board. If you can't see, then I'll do it on the next board. Tell me, suppose we have water, right? We have water here. We'll draw a normal like this. N dash. Clear?
Yes, sir.
Hello. This is the point of incidence. This is water air substance boundary. This is water air surface boundary. On this side it is air, and on this side it is water. You can write also medium 1 is air and medium 2 is water. Is this clear?
Yes, sir.
Yes, sir.
I have still not gone for the refraction. Now suppose an incident ray AO, right, which is in the plane of normal and surface boundary. They are all in same plane. The law of refraction, first law, is same as the law of reflection. Clear? But now it will not go in this side because this is not a polished surface. It is not opaque. So water bends little towards the normal. Suppose this is 45 degree and this becomes 30 degree.
Sir,
Wait, let me finish. Had this water not been there, this would have gone like this or not? Tell me. This would have gone straight, na?
Yes, sir.
This is the deviation. Vaidurjo, you are talking about delta.
Yes, sir.
This is called the deviation. The light deviated this much angle. Delta is angle of deviation from its original path. Normally we call it angle of incidence. We write R only, but this time it is not angle of reflection. It is angle of refraction. Clear?
Yes, sir.
Now this was the definition of refraction of light and with a diagram. Right? Now, if I reverse this, that means if I take water as medium 1 and air as medium 2, it will bend away from the normal. That will take up, in different cases. Note it down first. Draw the diagrams very carefully. I'm telling you.
Sir, may I ask now?
Yeah, you can.
Sir, you said that had the water not been there, the incidence ray would have gone a path that you drawn.
Yeah. Mm.
After that, you made the angle of deviation. Sir, my
Mm.
question is that if the water had not been there, won't the wouldn't have the angle of incident? I mean, the incident ray would have reflected out.
Hey, suppose there is a glass slab in front of me, right?
Yes, sir.
Suppose there is a glass slab in front of me. Okay, we will study that also.
Okay, sir.
Suppose there is a glass slab, right? Something like this. This is the
Yes,
normal. Incident ray is this,
yes,
right? Then
yes,
it bent towards the normal. Now, if I remove this glass slab, the incident ray will go like this only, na?
mm,
Repeat
yes,
your
sir.
question. Repeat your question once again.
Sir, I was asking that in this case that you shown the incident rate will go like this if the
Hmm.
glass slab hadn't been there. So
Hmm.
my question was that after going
Why
like
it
this,
is not reflecting?
yes sir, yes sir,
First of all, let me tell you, if I remove the water, what will be there? Air only, na?
yes sir,
So it is not traveling to the other transparent medium, na?
yes sir,
Right?
yes sir.
Wait, I have to edit my definition to another transparent medium having different optical densities is called refraction of light, which is, and reflection of light, you can write here. Reflection of, huh, refraction of light. Chichi. Refraction of light is essentially a surface phenomenon.
Sir,
Hmm.
let's say that as you drawn it, the incident ray is going and going and going until it found a polished and polished surface which can reflect it. It will continue to go.
Yeah, light will continue to travel here.
And sir, if it does not find a reflecting surface but another transparent medium, then it will refract.
Then it will refract.
Okay, sir. Understood.
8 minutes, 8 minutes, 8 minutes. Boydujo,
Yes, sir.
you have been given a car,
Car.
right? Suppose you are driving a car
Yes, sir.
whose fuel never ends,
Okay, sir.
and you have asked to drive it, right?
Okay, sir.
That's the order of your commander. Suppose,
I will have to keep
right?
driving.
You have to keep driving
Yes,
till
sir.
the road ends.
Okay, sir.
If the road never ends, you will keep on driving.
Yes, sir.
So that's the answer of your question here also. The
Oh,
incident ray will go on like that till the time either you get up, either your fuel ends, or you get a turning path or a roadblock. Then you will stop or you will turn.
yes, sir. Understood. Understood. Okay, sir.
Now here, water is optically denser than air.
So what is optically denser?
But optical density is a density which we should not confuse with mass density. What is mass density? Mass density is mass upon volume. Clear? Why I am saying don't take optical density same as mass density, because experimentally it has found for few substances, suppose there are certain gases. Due to gases also refraction can happen. No? I'm not talking about air.
Gases.
Whenever I write air, you should consider it as a vacuum. Clear? And light can travel in vacuum. We all know. Now in gases, what happens? One gas, suppose one gas has mass density less, but its optical density is high. So optical density and mass density, or density only, are two different terms. We should not be confusing it. You will not learn optical density till you do an MTech in fiber optics. So forget about that. Remember only one thing: optical density is not same as. Write it down. Optical density is not same as.
So is there a
Uh,
formula to find optical density?
the term optical density. The term optical. I am saying, note it down. The term optical density. Both of you. The
Yes.
term optical density is not same as the mass density. That's it. That much you should know.
Sir,
Yeah, tell
sir,
me.
copied.
So one second.
Have you written the sentence, Boyzurjo? Optical density is not same as the mass density.
Yes, sir. Written. Sir, one thing.
Today I was not in a mood to teach. But then again, I was feeling lethargic. Mentally, not physically. Had I been physically lethargic, I would not have shouted like this. Yes, one thing. Which thing? Which one thing?
Sir, you said that, sir, you said that the first law of reflection is equal to the first law of refraction, right?
Is same as first law of reflection. Only the thing is, you have to change the word reflection with refraction. And we will write the laws of refraction. Why you are worried?
No, sir, I was asking another question is that the
Yeah.
angle of incidence, why is it not equal to 30 degree for the angle of, I mean the angle where the light
Boydurjo,
reflects?
use common sense. Use common sense. Here I have just taken 45 degree as an example. This may not be right.
Yes, sir, I understood that, but
And I have taken 30 degrees also as an example. I have assumed 30 degree means what? It is bending towards the normal or not?
yes, sir. So that is why they are not equal. Okay, sir.
Yeah. Otherwise, I'll be using now onwards. I'll be using I and R.
Yes, sir. Thank you, sir.
They're done.
Done. Just give me 2 minutes. Now, there could be three possible cases. Okay. Then we'll discuss the cause of refraction. Case one, when incident light is traveling from an optically rarer to optically denser Guys, give me 2 minutes, huh? Yesterday being a Saturday, I was so tired that I could not refill my markers, which I have to do. So optically, denser medium. Now suppose this is water and this is air. Now this is the normal. This is your incident ray. Sorry. This is your incident ray, right? This is the surface boundary. This is water. This is normal. And this side is air. Now suppose the angle is I of incident ray and this angle is R. Can you all see this diagram? Has the refracted ray bended towards the normal?
Yes, sir.
Yes, sir.
Right? So the refracted ray bends towards the normal. Is it clear? Now case 2. Acha, one more thing. Here angle I is greater than angle R. Can you see that?
Yes, sir.
Yes, sir.
Case 2.
Sir, the reflected ray will bend towards the normal if the incident ray goes from rarer to tensile.
Yeah, optically rarer.
To tensile.
I'm writing optically rare and optically denser. Make all this diagram using scale pencil. Now case 2. When a light ray travels from denser to rarer medium, it bends away bends away from the normal, and the diagram would be something like this. I will just reverse this diagram, nothing else. I'll take water here now. And air, water, this is my normal, and this is the incident ray. Incident ray, this is refracted ray. So this is the incident ray, right? You can name it also AO, point of incidence, and OB. Again here also AO. It will bend away from normal. Can you see that? Here I is less than R. I is less than R. Angle I is less than angle R. Is this clear?
Yes, sir.
Yes, sir.
There are 3 cases. I have not drawn the third case. Draw it neatly, not free-handed. Use pencil scale. Again and again I am saying.
Drawn, sir.
Pratyasha,
Yes, sir. Done.
done.
Yes, sir.
Now there is a case 3. a light or an incident ray goes undeviated. Undeviated. That means it does not bend. Deviated while traveling from one medium to another. There could be two possibilities. So possibility one is, suppose this is my air, medium one, and this is water, medium 2. This is the normal. Right? Now the incident ray is along the normal. When incident ray, the refracted ray will go like this. No deviation. When incident ray is along the normal, along the normal, when incident ray is along the normal, right? Or perpendicular to the perpendicular perpendicular to the boundary separating two media, no refraction takes place takes place or there is no deviation in the path of incident ray. Right? Now suppose this is B. There is another case it can happen. This is medium 1. And this is medium 2. I'm not writing the names of the medium. This is incident ray. This will go undeviated. If the refractive index, if the refractive index, you must have already studied in school, index of both the media is same, there is no deviation, in the path of incident ray. Tell me once you have noted.
Sir,
Yeah.
if refraction does not take place, then
Hmm.
what will we call the rays that are going in the next medium, that is the second medium?
What will be the?
What will we call it? Like previously we were calling it refracted ray, but now
We'll, that is also refracted ray, undeviated.
oh, undeviated refracted ray. Okay,
Yeah.
sir.
Yeah.
And sir, then there then here in these two possibilities, I is equal to r, angle I is equal to angle r.
Yeah, which is equal to 0.
Yes, sir. Thank you, sir.
In case A, I is equal to R is equal to 0.
Yes, sir.
Right?
Yes, sir.
Here I is equal to R is equal to 0. Here only I is equal to R. It is not 0. You can see. It is not 0.
Yes, sir.
I'll be back from washroom 1 minute. Yes, I am back. Noted.
Yes, sir. Noted.
Pratyasha.
Yes, sir, noted.
Sir,
Yeah.
one thing I learned in class 7 is that
Hmm.
the normal is calculated to the mirror and not with the surface of mirror, for which it comes 0 degrees. Is that the same case in here? Except the mirror.
What?
In class 7, I read that
Hmm.
a ray of light which is incident normally on a plane mirror, the
Hmm.
normal is calculated, the angle of incidence is measured with the normal to the mirror and not with the surface of the mirror, for which the angle of incidence is equal to 0, not 90 degrees.
This is incident ray.
Yes, sir.
This is reflected ray. Now, what is your question?
Incident ray, reflected ray.
This
Same.
is angle of incident,
Yes, sir.
and this is angle of reflection.
Yes, sir.
Now, what you were saying, I could not hear it properly.
Sir, I was saying in case of ray of light, normally incident on a plane mirror, like in the case 3 that you did, uh,
Hmm.
like a straight one. That
Hmm.
one I am saying about. I am
Or
saying that,
refraction or reflection.
sir, in case of reflection, I was saying.
In case of reflection, it will retrace its own path.
Okay, sir.
So it
And
will,
now, sir, I was asking that why is it 0 degree but not 90 degree?
Because angle of incidence is the angle between incident ray and normal.
Okay, sir.
Few terms related to refraction.
Okay, sir.
Okay.
Yes.
Now, number one, what is the incident ray? The ray of light, the ray of light striking, striking the the surface, surface boundary separating two media is called incident ray. Number two, refracted ray. Acha, it's better we make a diagram here. Suppose this is the normal. This is medium 1. This is medium 2. Suppose this is the point of incidence. This is normal in N dash. And this is the surface boundary. suppose the ray deviates, so AO becomes the incident ray and OB becomes the refracted ray. So you can write, you have to make this diagram, then only if they ask you what is incident ray, refracted ray, right? So you have to explain with the help of a diagram. Here in the figure shown by AO, refracted ray. The ray of light, the ray of light, the ray of light traveling in the traveling in the other medium, in the other medium, in a in the changed direction, changed direction is called refracted ray, refracted refracted ray. Number 3, normal. The line drawn perpendicular to the surface boundary 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 separating two media, separating two media is called normal. And a point a point a point uh, on which the incident ray strikes the normal and surface boundary separating two media is called point of incidence. Point of incidence. Now, number 4, angle of incident or incidence. Angle of incidence denoted by I. Angle I. So it is the angle between, we all know what is angle of incidence. The angle between the incident ray and the normal is called angle of incidence. Number 5 is angle of refraction. Angle of, this is I, angle of, this is R. Angle of refraction, which is denoted by angle R. The angle between the normal and the refracted ray, the angle between the normal and the refracted ray is called angle of refraction. Before you start writing hello,
Yes,
hello,
sir.
no,
Yes, sir.
my question is to Pratyasha. Pratyasha,
Yes, sir.
this is a mirror, plain mirror.
Yes.
This is normal. Done? Understood?
Yes, sir.
Okay. Now this is incident ray and this is reflected ray. Clear?
Yes, sir.
What was this angle called?
Angle of incidence.
Very good. Boyjurjo, what was this angle called?
Angle of reflection.
Very good. Pratyasha, what was this angle called? I would have slapped you on your face.
The telling.
That, huh? Note it down somewhere in the corner. Glancing angle. প্রত্যাশা তোকে পড়িয়েছি আমি এটা glancing angle of incidence আর এটা glancing angle of reflection নোট করে নে এটা আলাদা করে নোট করবি if you can't carry out carry forward your knowledge to the next class what is the I don't have words. I mean, whatever I have taught, you have taken it for granted that you all are supposed to forget it. because 7 is over. Arey Baba, class 8 is built on 7. 9 will be built on 8. If you all don't remember all this, no one is going to write all this next year.
Sir, I did not know this one.
Which one? Glancing angle. Okay, you did not know. That is why I did not ask you.
Yes.
But write down now glancing angle of incidence. I don't have space to write on the right hand side. Glancing angle of reflection. Satyasha, what is the next chapter in physics? After light?
Heat transfer.
Huh?
Heat transfer.
They will go up to heat transfer, positive. Before the 15th November exam.
Sir, I've copied.
What about Bodhujo?
Sir, give me one moment. I'm just copying the.
Okay. No issues.
Thank
I
you.
don't know why I'm feeling tired because of Getting
Sir, I
already
think
normal.
sir, because I think you have been you did not get any
No,
break
my
or
son was out. My son was out of home. He returned quite late, so I went to sleep quite late. Normally by 10:30 it's end of the day. By 9:30 I take my dinner, and by 10 o'clock I go to the bed. After finishing all, normally you will see the IDs are sent a day prior to your class, always. Going to just note it down and tell me, pass.
sir completed.
Noted.
Yes, sir.
Now oral questions. Oral questions means very short answer type questions. Pratyasha, what is the angle of incidence?
Sir, the angle between incident ray and normal.
Guidudyo, what is angle of refraction?
Sir, angle of refraction is the angle between the normal and refracted ray.
Refraction. Oh. Now, have the school explain this. Why refraction happens? And you must have noticed in all my diagrams, refractions happens only in the medium 2. Light bends in the medium 2 when it enters. Am I right? Either it bends away from the normal or it bends towards the normal. You have drawn the diagram or not?
Yes, sir.
Yes, sir.
Check it out. So refraction always takes place in second medium, not in the first medium. Now, why the light bends? Refraction is bending of light, nothing else. Something has been discussed. Definitely, something has been discussed in the school regarding this.
No, sir.
Nothing.
No, sir. Sir, may I try this one?
Yeah. May I?
Try. I have a theory in head for which may this have, which for which this may happen.
Yeah. Tell me orally, verbally.
Sir, because suppose the light is traveling at a fixed speed in one medium, then suddenly when it transfers to another medium, its
Hmm.
speed decreases when in case of optically rarer to denser.
Hmm.
So what happens in that case is due to the sudden change in the speed of light, maybe that is
Hmm.
why the light bends.
Hmm. Okay. If I have understood you correctly, you said that if a light is traveling with some speed, say u,
Yes, sir.
right? Suddenly it enters a denser medium,
Yes, sir.
right?
Yes, sir.
And this is the denser medium, and this is the rarer medium,
Yes.
right? This is
Yes.
normal. This light is traveling like this. This is incident ray, AO, NN dash is the normal. It bends towards the normal, right? Here I is greater than R.
Yes, sir. Sir, I don't know
Acha,
if this is...
one minute, 1 minute. Suppose you are standing on a seashore. Pratyasha, listen to me carefully. Nobody
Yes.
will explain like this. Now you started walking from the sand, right? You are walking in this direction. Okay. Suddenly the water of sea starts from here. Right? If you enter into the sea, does your direction change? Or let's not take sea. Let's consider it as a pond. See, in case of ocean or sea, your direction may change because of the waves. Clear? Now, Vaidurjo, tell me, would your direction will change?
No, sir.
But your speed has definitely changed because you cannot walk as fast as you walk on sand rather than in water. In water, we can walk very slow.
Yes, sir.
Then why in the case of light?
Oh. Sir,
Hmm.
I don't know if this is related or not, but in class they said something about mu.
Hmm?
I don't know if this is related to the cause of diffraction or not,
No,
but
no,
in
no,
class
no,
there
no,
is...
no, no, no. That is related to laws of reflection.
Oh, okay, sir.
That is related to laws of reflection. Refraction. And yes, it decides the bending, but mathematically. But I am asking you theoretically, what is the cause of refraction? Considering that in denser medium, the speed of light will be less, and the rarer medium, the speed of light will be more. Chalo, let's do an experiment to understand this. Suppose this is your classroom. Is this clear?
Yes, sir.
This is your classroom. Ma'am took a chalk and draw a boundary clearly along one diagonal. Clear? Hello.
Yes, sir.
Yes, sir.
Now she selected 3 students. This is student 1. This is student 2. And this is student 3. And they are holding sticks in their hand. Is this clear?
Yes, sir.
Now, ma'am has said that you can walk at the rate of 2 meter per second. Ma'am also said this is zone 1. And she marked this as zone 2. Now the condition is What? All the three students can walk with 2 meters per second in zone 1. Clear?
Yes, sir.
And in zone 2, she has made it mandatory that none of the students should walk greater than a speed of 1 meter per second. Only 1 meter per second. Is this clear?
Yes, sir.
Yes, sir.
Now, who will reach the boundary first? The student?
Yes.
Correct?
Yes, sir.
This student will reach after him. This student will reach after him. Is this clear or not?
Yes, sir.
Yes, sir.
Everyone's speed is student 1, student 2, student 3. So student 3 hits the boundary first, student 2 after some time, and after this some time. Clear?
Yes,
Is this
sir.
clear? As soon as student 1 enters the zone 2, he has to reduce his speed. But he is not supposed to leave that stick. Say student 2 is somewhere here at that point of time. And this is the stick they have held. And student 3 is somewhere here. When the student 1 strikes the boundary, the position of the sticks is like this. Clear? Clear or not?
Yes, sir.
Now, after some more time, say student 1 is here and student 2 has just reached. Right? Has just reached. Condition is what? They cannot leave the stick. And student 3 is still here. And he can also can't leave the stick. Right? Now there is a condition comes when the student 1 is somewhere here and the student 2 is somewhere here. And now student 3 is entering. But still they have the stick. বুঝিয়েছে এভাবে?
No, sir.
Yes, sir. কি
Now
বললেন?
আমি বললাম এই একটা রে, এই একটা রে, এই একটা রে। আমার
হ্যাঁ।
বলার কথা হলো এই। ঠিক আছে?
হ্যাঁ।
এই রেটা বেন্ড হলো কিনা?
হ্যাঁ।
এই রেটাও বেন্ড হলো কিনা?
হ্যাঁ।
This is the cause of refraction.
The speed decreases in the zone 2, that is why they bend.
Yeah. Because first of all তিনজনের কাছে এই ডিসটেন্সটা সেম না। এটা এতটা, এর তার থেকে বেশি, এর তার থেকে বেশি। ক্লিয়ার? এবার আমি যদি এই স্টিকটাকে আরেকটা রে ধরে নিই তাহলে এখানে এই স্টিকটা এরকম হয়ে গেল কিনা?
হ্যাঁ
না আমি আলাদা করে ডায়াগ্রামটা বানাচ্ছি, এখন স্টুডেন্ট আর দেখাবো না, ছোট ডায়াগ্রাম বানাচ্ছি আমি। একদম ইনিশিয়ালি যদি রেটাকে এই স্টিকটাকে রে ধরি, এরকম ছিল কিনা? ছিল। আর এখানে বাচ্চাগুলো ধরে আছে এই স্টিক গুলোকে, দুটো স্টিক মিলিয়ে এরকম হবে, এই যে এটা ওকে।
ইয়েস
আর ফাইনালি কি হলো, এইটা স্টিকটা এরকম হয়ে গেল। ক্লিয়ার?
ইয়েস স্যার।
এবার এটাকেও রে নিতে পারো আর এটাকেও রে নিতে পারো, ডাজন্ট ম্যাটার। এই লাইনগুলোকেও রে নিতে পারো, বেল্ট তো হচ্ছেই প্রত্যেক। হচ্ছে তো?
হ্যাঁ স্যার।
This is how the speed affects. You will not explain like this. This is for your knowledge. Cause of refraction, note it down. First make this diagram, understand, try to understand. If you have any doubts, ask me.
স্যার তিনটে লাইট রে আছে আর সেগুলোর এক একটা ডিসটেন্স আপনার সারফেস বাউন্ডারি থেকে
Bend
আলাদা। হ্যাঁ, এবার ওরা যখন সারফেস বাউন্ডারিটা ক্রস করছে তখন ওরা বেন্ড হয়ে যাচ্ছে, কারণ ওদের স্পিডটা ওদের এফেক্ট করছে।
স্পিডটা, হ্যাঁ, প্রথম কথা টাইমটা বেশি লাগছে তো, স্টুডেন্ট ওয়ানের টাইম সবচেয়ে কম লাগছে। স্টুডেন্ট ওয়ানের টপ থেকে বটম পৌঁছতে সবচেয়ে কম টাইম লাগছে, স্টুডেন্ট 3 এর টপ থেকে বটম পৌঁছতে সবচেয়ে বেশি টাইম লাগে। ক্লিয়ার? তো লাইট অলসো বিহেভ, সি লাইটের দুটো নেচার আছে যেটা এখনো এস্টাবলিশ করা যায়নি, whether light is a pure wave nature, যেটা ইলেকট্রোম্যাগনেটিক ওয়েভস বলা হয়, যেটা আমি প্রথমেই লিখিয়েছিলাম, লাইট ইজ আ ফর্ম অফ এনার্জি ইন ফর্ম অফ ইলেকট্রোম্যাগনেটিক ওয়েভস, রাইট? আরে হ্যাঁ, noted the definition of light
Yes sir, yes sir.
in the first board, right? But
Yes.
till now the scientists are not. Light exhibits particle nature also, and if there is a particle, it has to have some mass. Come on, yeah.
Yes sir.
But electromagnetic wave does not have any mass.
It does not have mass.
No.
Okay sir.
That is why light has wave nature and particle nature. Now, in class 12 we will study, there are few phenomena like reflection and refraction. Reflection and refraction can be explained using wave nature of light and particle nature of light, both. But there are certain phenomenon of light which cannot be explained based on refraction, particle nature. There are certain phenomena of light. There are many phenomena of light. There is one called diffraction. So there are some phenomena which can be explained both particle nature and wave nature, and few phenomena can be explained based on wave nature only. And few things are there, definitely few things are there. They cannot be explained using wave nature. They can be explained only by using particle nature. Clear? This is just for your knowledge, no need to write all this.
Yes, sir. Few phenomena of light can be explained using the electromagnetic and a few
Not
explained.
electromagnetic, not electromagnetic, wave nature of light.
Okay, sir. And another particle.
There are two natures of light, particle nature and wave nature.
Yes, sir. Okay, sir.
Reflection and refraction can be explained on both. ক্লিয়ার? এবার যদি পার্টিকেল নেচার না হতো লাইটের, তাহলে আমি এই ডায়াগ্রামটা বানাতে পারতাম? আরে আমি ডায়াগ্রামটা কি দিয়ে প্রুভ করলাম? একটা স্টিক আর তিনটে বাচ্চা দিয়ে প্রুভ করলাম তো।
Yes, sir.
ছোট হোক বড় হোক পার্টিকেলই তো। Students are made up of particles only.
Yes, sir.
So
Yes.
that means it is a particle nature. And we saw the stick is bending. So if light has some particles, it will behave in the same way or not.
Yes, sir.
Now don't consider students. In the second diagram, I have considered light as a particle. And zone 1 is nothing but medium 1. And zone 2 is nothing but medium 2. Am I clear?
Yes, sir.
But for class 8, what you will write? Cause of refraction. The light refracts while traveling from one medium to another, having different optical densities, because the light has different speeds in different media. So cause of refraction is the light traveling from one transparent medium to another, such that both media have different optical densities bends in the second medium medium due to the fact that the speed of light is different in different media. Noted?
Yes, sir.
Satyasha,
So
write in the group. Wait a minute. I am not wiping it off, Boidujo.
thank you.
Satyasha, write in the group.
Yes, sir.
To start with laws of refraction. Make laws of refraction bold.
Yes, sir.
Written.
Yes, sir.
Message gone to the group.
No, sir. Now it is gone.
Gone. Okay, Boidujo, what you were asking?
Sir, I was telling that I still not completed.
Have you completed now?
Yes, sir.
Listen to me carefully, both of you. Satyasha, have you noted this, beta?
Yes, sir.
I am ending the meeting, but the class is not over. This is a break of 15 minutes.
Yes, sir.
The objective of starting the class early was to catch up mathematics and science both. Physics both. Right?
Yes, sir.
I will not record the class of mathematics. I am not interested. So, therefore, this recording has to be converted and I need 10-15 minutes time. Go for 10-15 minutes. I'll give you a call. Then join back. I'm ending the meeting now, but the class is not over.
Yes, sir.
Understood, Boidujo?
Yes, sir, completely.
We will start with construction of quadrilaterals.
Okay.
Okay, sir.